210.4 Derating of neutral conductor, specifically subsection B, addresses circuits supplying electric ranges. In a dwelling unit, the neutral conductor of a 3-wire branch circuit supplying an electric range must adhere to specific sizing requirements. It states that the neutral conductor of such a circuit shall not be derated below the size required by 210.19 A. Now let's break down what this means. Firstly, it applies specifically to 3-wire branch circuits supplying electric ranges in dwelling units. Secondly, the key is that the neutral conductor cannot be smaller than what is dictated by 210.19 A. So, what do 210.19 A specify? These sections deal with the ampacity of branch circuit conductors and specifically address ranges of 8.75 kilowatts or more rating. 210.19 A states that branch circuit conductors having ampacities not less than the rating of the branch circuit and not less than the maximum load to be served. For ranges, this means the branch circuit conductors, including the ungrounded conductors, need to be sized to handle the range's load. 210.19 ATWO provides an exception, allowing for demand factors in sizing the branch circuit conductors for ranges. It permits the use of Table 220.55 to determine the demand load for ranges. Table 220.55 is crucial here because it allows you to apply a demand factor, recognizing that a range typically doesn't operate at its full rated load continuously. Therefore, the neutral conductor sizing for an electric range circuit in a dwelling unit involves a two-step process. 1. Determine the minimum size required by 210.19 A and 2. Taking into account the demand factors from Table 220.55. 2. Ensure that the neutral conductor is not derated below that size as per 210.4b. In summary, 210.4b prohibits excessive derating of the neutral conductor below the minimum size dictated by the range's load calculated using the demand factors specified in 210.19 A and 2 in Table 220.55. Consider a scenario where you have an electric range rated at 12 kilowatts. You would refer to Table 220.55 to find the appropriate demand factor. Let's say the demand factor results in a calculated load of 8 kilowatts. You would then determine the minimum ampacity required for the branch circuit conductors, including the neutral, to handle this 8 kilowatt load, considering voltage and other factors. The neutral conductor size must be at least the calculated ampacity, and 210.4b prevents it from being smaller. The purpose of this rule is to ensure that the neutral conductor can safely carry the unbalanced load and any harmonic currents that may be present in the circuit. Insufficiently sized neutral conductors can overheat, leading to potential fire hazards. In practice, calculate the demand load for the range using Table 220.55. Then determine the minimum ampacity required for the branch circuit conductors based on this demand load. Select a conductor size with an ampacity equal to or greater than the calculated value, consulting ampacity tables such as those found in 310.15 of the Electrical Code. Finally, ensure that the neutral conductor is not smaller than the size determined in the previous step in accordance with 210.4b. For example, imagine an electric range with a nameplate rating of 10 kilowatts connected to a 240 volt circuit. According to Table 220.55, the demand factor for a single range is 8 kilowatts. The current can be calculated using the formula power equals voltage times current, so current equals power divided by voltage. Therefore, 8,000 watts divided by 240 volts yields approximately 33.33 amps. Based on this, you would select a conductor size from Table 310.15 that is rated for at least 33.33 amps. For instance, using a 75 degrees Celsius termination rating, a number 8 American wire gauge copper conductor, typically rated for 40 amps, would be suitable. 210.4b dictates that the neutral conductor must also be at least a number 8 American wire gauge copper conductor in this case. Consider a situation with multiple ranges where you might apply different demand factors from Table 220.55, which could affect the overall load calculation. Always prioritize safety and compliance with the electrical code when sizing conductors for electric range circuits. Remember to consult the most current edition of the electrical code for the most accurate and up-to-date requirements. When performing electrical work, always de-energize the circuit and follow appropriate safety procedures. Also, be aware of local amendments to the electrical code that may further modify or clarify the requirements for neutral conductor sizing. These amendments are often based on local conditions or specific concerns within a jurisdiction. Be certain to check with the local electrical authority to determine any applicable local rules. Harmonic currents, which can be present in electrical circuits due to nonlinear loads like electronic devices, can significantly increase the current flowing through the neutral conductor. Therefore, proper neutral sizing is important not only for handling unbalanced loads but also for mitigating the effects of harmonic currents. Certain types of ranges, such as those with electronic controls or induction heating elements, may generate higher levels of harmonic currents than traditional resistance heating ranges. In these cases, it's even more critical to carefully consider the neutral conductor sizing to prevent overheating and other potential issues. The use of appropriately sized conductors is not only a safety measure, but it also helps to improve the efficiency and reliability of the electrical system. Undersized conductors can lead to voltage drops, reduced equipment performance, and increased energy consumption. Proper conductor sizing ensures that appliances and equipment receive the correct voltage and current, maximizing their performance and lifespan. Keep in mind that the electrical code is a comprehensive set of rules and guidelines designed to ensure the safe installation and operation of electrical systems. It's essential to have a thorough understanding of the code and to follow it diligently when performing electrical work. If you are not a qualified electrician, it's recommended to hire a professional to perform any electrical installations or repairs. Working with electricity can be dangerous, and it's important to take all necessary precautions to prevent accidents and injuries. When sizing conductors, be certain to consider the ambient temperature and the number of conductors bundled together in a raceway or cable. High ambient temperatures can reduce the ampacity of conductors, and bundling multiple conductors together can also reduce their ampacity due to heat buildup. Correction factors and adjustment factors, as outlined in Table 310.15 of the Electrical Code, must be applied to account for these factors. In addition to the Electrical Code, there may be other applicable standards and regulations that need to be followed when installing electrical systems. These may include local built-in codes, energy efficiency standards, and safety regulations. It's essential to be aware of all applicable requirements and to comply with them fully. In some cases, it may be necessary to consult with a qualified electrical engineer to ensure that the electrical system is designed and installed in accordance with all applicable code and standards. An electrical engineer can provide valuable expertise in areas such as load calculations, conductor sizing, and overcurrent protection. The use of appropriate overcurrent protection devices, such as circuit breakers and fuses, is also essential for protecting electrical circuits and equipment from overloads and short circuits. Overcurrent protection devices must be selected with the correct ampacity rating and interrupting capacity to adequately protect the circuit. The electrical code provides detailed requirements for selecting and installing overcurrent protection devices. Grounding and bonding are also critical aspects of electrical safety. Grounding provides a path for fault current to flow back to the source, allowing the overcurrent protection device to trip and to energize the circuit. Bonding ensures that all metal parts of the electrical system are electrically connected, reducing the risk of electric shock. The electrical code provides detailed requirements for grounding and bonding electrical systems. Regular inspection and maintenance of electrical systems are important for ensuring their continued safety and reliability. Electrical systems should be inspected periodically for signs of damage, wear, or deterioration. Any problems that are identified should be repaired promptly by a qualified electrician. Maintenance activities may include tightening connections, cleaning equipment, and testing overcurrent protection devices.